Hello! As you know, white color is a mix of all spectral colors. So, what is the black color then? Absence of light? Actually, yes. Black bodies absorb most of visible light and our eyes detect it like its absence. But we see it. So, it means for all that, piece of light has reflected and reached us. Now look at this. The darkness inside the box is considerably darker than it was. Why? The light which falls into the hole is reflected and absorbed by walls many times, but stays inside. It turns out that this hole absorbs all radiation that falls there. Such hypothetical object is called the perfect black body. Of course, this model is not ideal. Some light was reflected and it went out the box, but where is this light from? The major part of the light we take is from the sun. When we don't have it, a good way to get the light is to heat something. This heat radiating makes light. But in what way? According to Gustav Kirchhoff's law, the quotient of energy that was radiated by body by absorption coefficient is constant. It means that it doesn't depend on material. And as a matter of fact, if we take the body which has reached thermal equilibrium, it means that it radiates as much energy as it absorbs. Then radiated energy would be proportional to this absorption coefficient. In fact, for every frequency, the quantity of radiated and absorbed energy is equal. It is a detailed balancing principle. It implies that the function that describes these processes exists, and it depends only on temperature and frequency. So the perfect black body is ideal for researching because, according to definition, it has absorption coefficient that equals 1. Great, isn't it?
So this function should be found. The Rayleigh-Jeans law that was based on classical thermodynamics was a good try, but it had a significant problem. It works only with long-wave radiation. Pursuant to this law, the energy grows unrestrictedly with the frequency. It was called ultraviolet catastrophe. Another try was better. Once displacement law predicted peaks of radiation intensity very well, and it added that this intensity depends on combination of frequency and temperature. But as opposing to Rayleigh's rule, it wasn't right with long-wave radiation. Max Planck decided to come down to the point counterwise. He put into our familiar model of black body electromagnetic oscillators in thermal equilibrium, which created and resonated the radiation. And the amount of energy that radiates and absorbs by oscillators could be calculated with such formula. But in 1897, Ludwig Boltzmann appeared with his report, and he criticized his point of view. By this performance, he allowed to Planck to use his molecular theory and probabilistic interpretation of principle of entropy increase. Having examined Boltzmann's works, probably he noticed the similarity between graphics of black bodies radiation and velocity distribution of gas molecules. And finally Planck decided to use the statistical method. For calculating of energy, it is necessary to find out the entropy S. For that we should know the probability omega, and for that it is essential to find out all possible system configurations according to common energy of all oscillators. It makes Planck suppose that energy consists of discrete elements, quanta, and they should be proportional to frequency, where the h is Planck's constant. And after some modifications, we get the law.
This formula, and particularly the quantum hypothesis, have enormous importance for modern science. It has given scientific substantiation to theory that allows us to judge about physical features of objects placed on million light years distance away from us, according only their light. And of course, it gave birth to new science discipline which changed all conceptualizations about our world structure: quantum mechanics. Thanks for watching.